There are 693 tiles in Terraria. When arranged in specific ways, they can mean more than just an array of tiles in the game. NPC housing, wiring, and pixel art are examples of this. Taking NPC housing for example, not only is it interpreted as an array of tiles, but also a place where NPCs can live. But pixel art is more interesting. Where computers interpret pixel art as an array of tiles, humans can interpret this as an image. By extension, the world file could be interpreted as a folder storing files, or something like a zip file. But this is just storing tiles that look like an image, not an actual image. But what if we could store an image in Terraria, or even better, store any arbitrary file? Well, first we need to look at a text file. If we simplify it and say there are only 26 valid characters, we could then take 26 different tiles from Terraria and match them to each character. Here's an example of what that would look like. In this clip, I'm writing out crawdad. Well, actually I'm not, I mixed up the L and the R, but you get the point. In theory, we could store a text file in the world, given that it only has characters A to Z. But this isn't overly efficient. As like said at the beginning of the video, there are 693 tiles we could use. Now before I go further, this topic was talked about before by BK Binary. In his video where he talks about playing Minecraft inside of Terraria, his comments point out in his previous video where he saves a file in Minecraft that the same thing would be possible inside of Terraria. But that wasn't the topic of his video, and as far as I'm aware, I couldn't find anybody else doing this. Which brings us back to this video, where that is what I'm gonna do. So with the 693 tiles in the game, we can match each tile up to a single byte. I assume you already know what a byte is, but if somehow you don't, to put it simply, it's made up of 8 bits. Each bit can either be 1 or 0, and 1 byte can store a value from 0 to 255, which is 256 possible values. And a file is just a list of bytes. So a text file, image, and exe are all the same thing, meaning if I can upload one file, I can upload any other one. So I created a mod that would allow me to upload, save, and read files into a Terraria world. This was also not made with Tmod Loader. This is technically vanilla Terraria, so don't ask for the mod in the Steam Workshop as it's literally impossible to put there. And I'm not rewriting the code for Tmod Loader because of its ridiculous proprietary methods for things like modifying tiles. Having native access to the 2D tile array is way easier than going through whatever this read-only tile map struct is. I did have to create my own mod loader called CMod Loader for vanilla Terraria, but this was still easier than making a mod for Tmod Loader. It's also not out yet, so I can't even release a mod compatible with it. Anyways, when storing a byte as a single tile ID, this is what this zombie PNG would look like. A couple things to note. First of all, this zombie is actually a pet. For the Terraria veterans or those who have seen my mobile 1.0 videos, this is a pet exclusive to the old mobile versions of Terraria. It just happened to be the first image in my downloads folder that was a good size for testing. And secondly, I'm sure some of you are wondering, why doesn't this image look like an image? Well, that's because it was saved as a PNG, and PNGs do a lot of compression. Therefore, if you wanted a visible image in Terraria, you'd have to store it as a raw image, which could be done, but that's storing images in Terraria, not an arbitrary file. But this image isn't overly optimized. Because one tile is 1 byte, we end up wasting most of the tile IDs. If we wanted to do this optimally, we would have to convert base 256 to base 693. So after adding the code to do that, this is what we get. This time it's a 256 by 256 PNG. Here are the image specs in case anybody wants to reverse engineer it. All of the other images in this video are going to be this one. However, I won't show you what the image is. Anyways, it converted 4,384 bytes into 3,717 tiles. But we can go further. Each tile can contain a wall. With there being 347 walls in the game, it means one tile can have 240,471 different combinations. And this is what it looks like in the world. And as you can see, it's now about half the size, now fitting in an area of 48 by 41 tiles. And this is what it looks like in the map. But we can go even further. We can use the 4 wires and actuator to bring the total combinations up to just over 7.5 million. And this is what it looks like in game. It doesn't look too different now, but when I turn on the wires, it looks way different. And at this point, there is a slight disclaimer. Everything breaks when loading in the world. This means that when logging into a world, your file gets all destroyed. This could be avoided by only using blocks that wouldn't break, but that would require going through every possible tile combination, but that would take way too long. Plus, this video was about saving a file in the world, not retaining mission critical data. The file could still be read through the world file, or you could use tedit, which would technically make it very secure data as nobody would suspect a file being saved in a world file. Anyways, I'm sure you're wondering if we could even take this further. And we can use paint for tiles and walls to bring the total combinations up to 7.8 billion, which would look like this in game. As you can see now, it takes up significantly less space, only requiring just over 1,000 tiles to store a 4.8 kilobyte file. But at this point we're reaching the limits. There aren't very many values that would add a significant boost to the combinations, so it requires us to use some unconventional values such as slope, active state, liquid type, Fulbright, and invisibility state for both walls and blocks. Now you'd think some of these values such as slope and liquid type only apply to certain tiles, but apparently they apply to all of them, so a sloped furniture would exist. Now it should be noted that there are technically other values we could have used. In theory, we could have used both variables frame x and frame y, which would have brought the total combinations up to 33.8 quintillion. That is this number for reference, but unfortunately these values change every every frame, as they're used for rendering tiles, which means that the file would change every time the game renders a frame. I'm not even sure if it would be able to render. It seems it would function properly as transmutation utilizes these values, but anyways, adding the previously mentioned values would bring the total combinations up to 4 trillion, which would look something like this. Now you may notice that there are a lot of missing tiles and walls. At this point, if you were trying to decode it, it would be impossible, due to the blocks and walls being invisible or being inactive. Despite this, it only takes up 818 tiles, which is about 5.3 bytes per tile, and is still able to be read back properly. But speaking of reading back, instead of reading a file we put into the world, we could read the world and put it into a file. The same code that reads back tile data can read any tile data, meaning we could read back any given structure and save it into a file. We could then save that file back into the world. Unfortunately though, it doesn't keep the frame position, meaning every tile is displayed as the first position on the tile sheet. I could fix this by including the frame position, but that's not the point of the video. But have we reached the limit? Are there any other values that we could even use? Well, in theory we could use the frame position like mentioned previously, but we could also just utilize all the unused tiles. In theory, there are 65,536 tiles, as the game stores the tile ID in a 16-bit variable, so I tweaked the code a bit to allow every single tile ID possible, but unfortunately the game just crashes, as it tries to index information from a tile that doesn't exist. And without going through every single tile to get compatible values, this is basically the limit. It might be able to load the image off screen, which means the game wouldn't try rendering it, but then I can't show it on video. Tmod Loader may have helped with that, but I didn't feel like testing it. But I'm sure you're wondering, what's the largest file we could save in a Terraria world? Well, assuming we go with the 4 trillion combinations per tile, and with there being 20,000 tiles in a large world, doing some math, the answer is only 105 megabytes, which wouldn't even allow you to store the entirety of Terraria. The exe would fit as it's just under 20 megabytes, but the 600 megabytes of textures and other data would not fit. Even compressing things into a zip file was still too large. So is there any other way we can store any more information in the world? Well, in theory, yes, but it couldn't be done within Terraria. Because the variables for time frame position are saved when saving the world, we can multiply the previous combination count of 4 trillion by 65,536 two times. This would bring the possible combinations up to 17 sextillion. That's 21 zeros for reference. With this, we could store 186 megabytes. Still not enough to store the entirety of Terraria, but is there any way to store Terraria within Terraria? At the moment I'm not sure, but there might be a possibility. So far we've only looked at tiles, but we could also look at chests. That is beyond the scope of this video as I've not looked into it too much, but if we do the math as a proof of concept with the insufficient knowledge I have, or if we assume that every possible item ID can exist in a chest, which might not be possible, but for the sake of this video we're gonna say that all the IDs could exist if the items aren't updated, and if the stack can be the maximum possible value, each item could store up to 8 bytes. Multiply that by the 40 slots in a chest and the 8,000 chests possible in a world, we get about 2.5 megabytes. Not that much compared to if we use tiles. Now like I said, this is beyond the scope of this video, as there are many different types of values we could change within an item, such as damage, scale, knockback, value, reforge, and so many more. And I'm sure some of those values don't even save when saving the world. So if I make a part 2, I will have to figure out how large a Terraria world file could even be. That's assuming Terra still doesn't do it first.